Hello, we're going to go through 3.2 worksheet, excuse me, applied Pythagorean theorem problems. One of the things that we have to do here more consistently is show a labeled sketch that'll allow us to kind of set up and do the work correctly here. So let's take a look here. Number one, the foot of a ladder is placed 6 feet from a wall. So here's my wall. Right angle with the ground here. Here's my 6 feet. And here is my ladder. Okay. If the top of the ladder rests 8 feet up on the wall, so that means this is 8 feet. 8 feet there. How long is the ladder? Okay, so I'm going to use L here for this ladder. Now in real life you could just measure the ladder, but this is a hypothetical problem. We don't see the ladder, we can't take a tape measure to it, so here we go. So again, like in the past, my legs are 6 and 8, so I'm going to square those and add them, and that's going to equal my hypotenuse, which is my ladder in this case because it's across from the right angle. So here I get 36, here I get 64, and L squared still here. I get 100 equals L squared. And again, like we did with our previous assignment, we're going to just go ahead and do the square root step. So we get plus or minus 10. Ladders can't be negative, and we're talking feet, and we are done. Alrighty. So again, a ladder problem. Pretty straightforward once we got the sketch going here. Another ladder problem. The bottom of a ladder must be placed 3 feet from a wall. So again, I'm going to go ahead. There's my wall. There's my 3 feet. And again, we're assuming a right angle. If the ladder is 12 feet long, so now we know the ladder, how far above the ground does the ladder touch the wall? So I'm going to call this X right there. So again, we do have a right triangle. We do know 2 of the 3 sides, and we're looking for one of the legs here. So I'm going to go 3 squared, x squared, 12 squared in this order. So again, I'm going to subtract this 3 squared over. It's kind of a slick step here. Calculator, we get 135. And again, next step to find our height that we can reach up the side of the wall. We can square root that. And I'll do that on my calculator here. And I get 11.6, approximately plus or minus 11.6. And again, I can't have negative, and we're talking feet, so we're done. So really a 12-foot ladder reaches almost 12 feet up the wall with the ladder itself. Okay. Remember ladder safety. Always have a good distance away from the base so you cannot tip over. Moving on. John leaves school to go home. He walks 6 blocks north and then 8 blocks west. Okay. So here's John in school. He walks 6 blocks north, which is usually up, and 8 blocks west, which is usually left on paper. And north and west do form a right angle. How far is John from school? So we're looking at, I'm going to call this D for distance. Okay. So, right triangle, yes. No 2 sides, yes. Looking for the third, yes. Pythagorean theorem. So 6 squared, 8 squared equals D squared. So this is just like our first problem. This is going to come up to be 100. Square root, I get plus or minus 10 exactly for my distance. And these are blocks. And I don't have negative blocks here. Alrighty, moving on. Scott wants to swim across a river that is 400 meters wide. Ooh, that's dangerous. He begins swimming perpendicular to the shore he started from, but ends up 100 meters downriver from where he started because of the current. So here's my river. Shore here, shore here. It's 400 meters across. Okay. He starts swimming at a right angle, but he ends up 100 meters downstream. So how far did he actually swim? So here is my distance here. So again, right triangle, check. We know two sides, check. We're looking for the third, check. And this time we're looking for the hypotenuse. So again, 100 squared plus 400 squared, those are our legs, equals my kind of diagonal hypotenuse. I'm just going to calculate this all at once here. And I get, wow, big number, equals x squared, square root. It's good to leave that number in your calculator. So we're going to get 412.3 meters plus or minus, rounded, and only want the positive one, so we get that. So again, another nice rhythm going here. Sketch, decide on your situation, and set up your equation. Go here. A ramp is placed from a ditch to a main road 2 feet above the ditch. The length of the ramp is 12. So here's my 2 feet. My ramp is going to be the sloped part. And usually if we say it's above, it's directly above, perpendicular, right angle. How far away is the bottom of the ramp from the road? Okay, so we're looking right here. So again, right triangle, check. We know two sides, check. Looking for the third side. Yes. So leg plus the other leg equals the diagonal hypotenuse. X squared equals, I'm going to subtract that 2 squared over. That's going to give me 140. So x will be about plus or minus 140 square rooted. 11.8. We're talking feet. And we're pretty good there. Oh, I changed colors accidentally here. Only want the positive one, of course. Oh, let's change up to kind of orange here. I like orange. A soccer field is a rectangle 90 meters wide and 120 meters long. So, rectangle 90, 120. Okay. The coach asks players to run from one corner to the corner diagonally across. So we're trying to find this. It's a rectangle. We know that. And we're looking for that. Okay. Okay. So right triangle, yes. Do I know two sides? Yes. Looking for the third? Yes. So Pythagorean kicks in, looking for the hypotenuse. Oh man, that's like the worst 9 ever. So if I take 90 squared plus 120 squared equals x squared, I'm going to go ahead and calculate that sum of squares. 225.00 equals x squared. And I'm going to square root that while it's still on my calculator. I get 150 meters plus or minus x. Oops. Plus or minus equals. And I only want the positive one. 150 meters. If you did that twice, it'd be 300 meters. Moving on here, second to last one here. baseball diamond is a square with sides of 90 feet. So I'm going to go ahead, 90, 90, 90, 90 for a square. And it has right angles. What is the shortest distance between first base? So let's say this is home. So first base is here. Third base is here, so we're looking here. Like I said, a square has right angles as well as 4 equal sides. So again, I'm going to set up 90 for one leg, 90 for the other leg, and x for the distance across, or hypotenuse. I'm going to go ahead and calculate that. And we get 16,200 for x square root. So I'm going to go ahead, jump on the calculator here. I get 127.3 feet approximately, plus or minus, but I only want the plus. So there you go. Not too many times will you run from first to third directly, but a lot of times there'll be throws from third to first or first to third. And finally, TV screens. So again, Donna's TV screen is 20 inches long, so TV screens are usually rectangular, 20 inches long. The diagonal, which is what they advertise for your TV size, so if you buy a 70-inch TV, huge, but that's that diagonal, that's not the height or the width here. It is rectangular, and it says long, what is the width? They must want to call that the width there. Okay, so again, right triangle, check. Do I know 2 of the 3 sides? Check. Looking for the third side, check. I'm looking for a leg, so w squared 20 squared equals 25 squared. I'm going to subtract this 20 squared over. These cancel. I get w squared equals 25 squared minus 20 squared. Should be 225. Exactly, square root, square root. W equals exactly plus or minus 15. We're talking inches, and no negative. So again, a good rhythm here with these problems. Hopefully this helps you clean up any errors you had initially. And again, have a good day doing a little bit of math.